Hi everyone and welcome back to this series. In this video, we'll use optimization to automatically adjust our components values so that the filter meets our design goals. Now, optimization works by allowing the software to change selected variable in order to reach specific measurement goals that we will specify later on. Now, before running the optimizer, we need to select the variables in the circuit that are allowed to be changed. Now, we're going to do this similar to the way we did in the tuning. We're going to open our variable browser over here. And we're going to allow optimization for certain variable. We're going to allow the same one that we changed for tuning. Now, once this is done, we need to assign our goals for our optimization. First, I want to focus only on the passband and stopband graph. I'm gonna close this one and disable it. I'm gonna open this graph over here. And there's two main ways to create optimization goal. I can either go to my project browser over here, go to my optimizer goals, right click and click add optimization goal. And over here I specify the measurement and then assign a certain goal, or I can either go over here, right click on a certain measurement and click on add optimization goals and just draw the goal on my graph. I find it very helpful and this is the way that I like to do it. Now I want the measurement to be less than my goal. I want to use the minimum. I want to stop at 500 megahertz and maybe the goal to start at -17 and the weight is 1.0. Now, the more that I increase the weight, the more it is important for my measurement to meet the goal that I specified. Now, I'm gonna do the same for S22 as well. Let's add an optimization goal. Let's draw it over here. Let's click on OK. And then for S21, I want my measurements to be bigger than -3 dB. So my measurement is bigger than my goal, use minimum, and it is very important for this goal to meet, for this measurement to meet this goal. So I'm gonna put the weight as 4.0 and then I'm gonna click on OK. Now the next step is to run my optimization, and to do this is I'm gonna click on simulate and then optimize, and here I have my optimizer window. Over here I choose the different available methods. Random is a good method, gradient is as well a mathematically accurate method. Now I'm gonna keep on random. I'm gonna choose 50 iterations for now. The number of parallel jobs depend on the number of cores you want to use during the optimization. For now, I'm going to keep it as 1, and the variation factor, I'm going to keep it as 0.1. And then let's click on Windows. Let's do them horizontal. And let's start our optimization. Okay. Now, during optimization, the software repeatedly adjusts the selected variables and evaluates how well the circuit meets the defined goals. And you can notice that our goals were met with 14 iterations and it didn't need 50 iterations. And you can see that this cost over here, it is 0, and the cost indicates how close the design is to achieve the goals that we specified. A lower cost means the design is closer to the desired performance. Now, once the optimization is finished, you can notice here the variables, the values for our variables have changed and are now with the values that will give us the graph that meets our goals, and our graphs has been updated with the selected variables. For example, we can maybe drag this a bit lower. We want our S11 and S22 to also be a bit lower. And we can try to run our optimization again. And as you can see now, it took 50 iterations. The cost is very low, but it's not 0, meaning there are still some changes that needs to be done to meet our certain goals. Now, in this video, we use optimization to automatically adjust component values and improve the performance of our low-pass filter. In the next video, we'll perform a yield analysis to evaluate how manufacturing tolerances may affect the circuit's performance. Thank you, and I'll see you in the next one.